These two problems are slightly different from the previous problems because we're no longer dealing with the polynomial divided by a polynomial. We have a polynomial in the numerator, but we have an irrational function in the denominator. So the question is, do the same methods work? And the answer is yes. If we were going to look at the skill piece, I'd be looking for the highest power of x in the denominator, and that's the x squared, but what I'd have to consider is that it's the square root of x squared. So I would be dividing all four terms by the square root of x squared and then working the algebra from there. You can still do dominant terms. So that's the approach I'm going to take. The limit for this one, the limit as x approaches infinity, and the dominant term in the numerator is x. The dominant term in the denominator is all of that. So it is the square root of 4x squared. So a little bit of algebra here. The square root of 4x squared is equal to the square root of 4 times the square root of x squared. So this is very simply a2x. So this is the same thing as the limit as x approaches infinity of x divided by 2x. My x's cancel out, and the limit as x approaches infinity is 1/2. So it's tempting to say that yes, we just have one asymptote here, but this is where you have to actually stop and think about what you just did. We did the limit as x approached a positive infinity, so this is positive, no big deal. Positive divided by positive is positive. But if we take a look at this again, the limit as x approaches infinity of x over the square root of 4x squared, and think about a negative infinity, then my numerator is going to be less than 0. But if you look at my denominator, I'm taking my negative infinity and I'm squaring it, so it's positive times 4, which is positive, and the square root of a positive does exist, so my denominator is greater than 0. I have a negative divided by a positive, and that is a negative number. So this limit here is actually equal to negative 1/2. So this function has two asymptotes. So my horizontal asymptotes are y equals 1/2 and y equals negative 1/2. So it seems kind of tricky, but if you're looking, they should be fairly obvious because it's not just a polynomial over a polynomial. You have a square root. And then I have an x squared inside of my square root, but just stop and think about it. Doesn't matter if you put in a positive number or a negative number. If you look at this problem, 3 times a positive infinity minus 2, that's infinity. 3 times a negative infinity minus 2, that's negative infinity. So I have a positive for one and negative for the other, but in my denominator, they're both positive. Negative infinity squared is positive, making all this positive. Positive infinity squared is positive. So I'm going to end up with two answers for this one as well. So if I look at my dominant terms, I have 3x, and then down here I have the square root of 2x squared. And I'm going to apply two limits to it. Okay, so 3 times infinity is just infinity. Infinity squared, infinity times 2 infinity. Square root is another infinity. This denominator can be simplified to the square root of 2 times x. The square root goes to both, and then the square root of x squared is just x. So this is the same thing as the limit as x approaches infinity of 3x over the square root of 2x. So this equals 3 divided by the square root of 2, and everything was positive. Here I'm going to get the same answer, except my numerator is negative, my denominator is positive, so this will be a negative 3 divided by the square root of 2. So again, this has two asymptotes, y equals 3 divided by the square root of 2, and y equals negative 3 divided by the square root of 2. So we have two asymptotes for each of those. Now, one last problem to look at where your algebra skills might fail you. You have y equals sine x divided by x. So you think, I'm going to take the limit as x approaches infinity, and we have sine x over x here, and the limit as x approaches negative infinity of sine x over x. So you want to plug in an infinity into sine, or negative infinity into sine. And that's where you're not going to have an algebra skill that saves you. You have to stop and think about the size of something. Which is more dominant, sine or x? So if you think about the sine function, it oscillates, goes back and forth. It's a wave function. So as I go to the right, the highest it can get is 1. The lowest it can get is -1. As I go to the left, the highest value it can have is 1. The lowest value it can have is -1. So basically, this function is something between -1 to 1. But you're dividing by something absolutely huge. So you're dividing by an infinity. And it doesn't matter what number you have in here, from -1 to 1, you are actually dividing by something much larger. So both of these are going to go to 0. So this is actually something known as the squeeze theorem that we'll look at a little bit later, a little bit more formally.